You probably learned this in school. Oil comes from dinosaurs. We've all seen the illustrations. Giant reptiles sinking into swamps, slowly liquefying into the fuel that powers our world. It sounds logical. Massive creatures creating massive reserves. But here's the problem that's going to mess with your head. Even if every single dinosaur that ever walked the Earth turned 100% into fuel, it wouldn't account for even a fraction of the oil we've actually pulled out of the ground. Not even close. That's because the total biomass of every dinosaur combined was tiny compared to something else that existed in unimaginable quantities. Something much smaller, something almost invisible. This is where the real mystery begins. Across Earth's history, vast shallow seas repeatedly covered enormous portions of the continents. Places that are now sun-scorched deserts or jagged mountain ranges were once tropical, underwater graveyards for millions of years. Life thrived in those ancient seas, specifically one known as the Tethys. Yet oil is strangely concentrated in just a handful of specific regions, like the Middle East, while most of the planet has virtually none. So the real question is no longer, where did oil come from? The real question is, why did this one specific ancient ocean create a lottery win that changed the course of human history? If ancient seas were everywhere, why do we only see this level of oil wealth concentrated in the Persian Gulf Basin? To solve that, we have to look at the first of our three puzzles, the Tethys Trap. Most oceans are like giant lungs. They breathe. Currents circulate oxygen from the surface down to the depths. In a normal ocean, when a microscopic organism dies, it falls to the seafloor and is immediately eaten by bacteria or scavengers. It rots. It disappears. But the Tethys was different. Because of the way the ancient continents of Gondwana and Laurasia were positioned, the Tethys was shaped like a giant, stagnant wedge. It was a nutrient-rich superbay with restricted circulation. In these deep, quiet pockets, the water became anoxic, meaning it ran out of oxygen. Imagine a world where nothing rots. As trillions upon trillions of microscopic plankton died, they rained down into a dead zone where no bacteria could survive to eat them. Instead of decaying, they formed a thick, black, organic sludge. In some parts of what is now the Middle East, this layer of source rock is kilometers thick. It was nature's way of hitting the pause button on death. But having a pile of organic sludge is just the beginning. It's raw ingredients sitting on a counter. To turn it into oil, you need a kitchen. This brings us to our second puzzle, the tectonic sandwich. Having organic matter is useless if it's just sitting on the surface. To transform that sludge into liquid energy, it needs to be buried and cooked at a very specific temperature, usually between 100 degrees and 150 degrees. If it's too cold, it stays as useless muck. If it's too hot, it overcooks into natural gas or burns off entirely. This is the oil window, a delicate geological tightrope. About 20 million years ago, the chef arrived. The Arabian plate began to drift north, eventually slamming into the Eurasian plate. This wasn't just a collision, it was a slow-motion crushing machine. This tectonic sandwich pushed the organic layers deep into the Earth's crust, right into the sweet spot of the oil window. The heat and pressure began to crack the long organic molecules into the shorter hydrocarbons we call petroleum. It was a perfectly timed gourmet process. But here is the problem. Oil is lighter than water. As soon as it's created, it wants to float upward, through the cracks in the rock, until it reaches the surface and evaporates into the atmosphere. This is our third and perhaps most vital puzzle, the Great Seal. If the oil was made, that's one thing. But keeping it there? That required a geological miracle. As the plates collided, they didn't just heat the oil, they folded the Earth into giant arches called anticlines. These act like massive upside-down bowls, but a bowl only works if it has a lid. In many parts of the world, these lids are made of leaky sandstone. But in the Middle East, the ancient Tethys had one final gift. As the sea periodically dried up millions of years ago, it left behind massive, thick layers of salt and anhydrite. These minerals are completely impermeable. They are the ultimate Tupperware seal. The oil rose up, hit these salt caps, and had nowhere else to go. It was trapped in the greatest storage system ever designed by nature. So, if the Tethys was the kitchen, the tectonic plates were the oven. and they just turned the heat up too high in other places but kept it perfect here. But here is where it gets even more interesting and messy. This wasn't just a single event. It was a series of perfect lottery wins stacked on top of each other. If the plates had collided a few million years earlier, the oil would have burned away. If the salt layers hadn't formed, the oil would have leaked out before humans even evolved. When we look at the geopolitical map of the world today, we aren't looking at the results of hard work or modern strategy. We are looking at the footprint of a vanished ocean. The borders of the world's most powerful oil states align almost perfectly with the deep water trenches of the Tethys. Now, some might point to the red herring theory, the idea of abiogenic oil. This is the claim that oil isn't biological at all, but a mineral formed deep in the Earth's mantle that just seeps up. It's a popular villain in scientific circles because it suggests oil might be infinite. But if that were true, we would expect to see massive oil pools in the middle of solid granite continents or at the bottom of every deep trench on our Earth. But we don't. The ultimate proof comes from the chemistry. When we look at Middle Eastern oil under a microscope, we find biomarkers, chemical fossils of specific Tethys plankton that could only have existed in that specific sea at that specific time. The signature is undeniable. This realization changes the way you look at the world. We often talk about the Middle East as a place of sand and heat, but beneath that sand is the ghost of a cold, dark, oxygen-starved ocean. Every time you start your car or buy a plastic bottle, you are consuming the concentrated energy of trillions of tiny lives that were snuffed out in a stagnant bay 100 million years ago. It's a reminder that global power isn't just about politics or armies. Sometimes, it's about who happens to be sitting on top of a prehistoric accident. The Middle East isn't an oil giant because it's a desert. It's an oil giant because it's the final resting place of a sea that refused to let its life rot away. It is a one-time-only geological miracle, a perfect storm of biology, chemistry, and physics that we simply cannot replace. When we understand the Tethys secret, the geopolitical cynicism fades away and is replaced by a terrifying sense of scientific awe. We are living off the dividends of a lottery win that took 200 million years to draw. And once that prize is spent, there is no second ticket. Do you think the world will find a real alternative before the oil runs out? Or are we cutting it too close? Drop your answer below.